Hello, hi, and welcome to Day 7, Session 2 of the IEEE Region 8 Virtual SIP Congress. We have quite a day lined up. During the next session, we have the Entrepreneurship Finals, and they will be going through the 6 finalists of the Entrepreneurship Initiative. Then we have IEEE Nigeria with their YP chair and their section chair. And then last night, we will be having a professor from the Florida University speaking about technology for improving healthcare and treatment. But before all of that, it is my great pleasure to announce someone who throughout her career has had roles including product manager for Mozilla, product manager for Qualcomm, operations with Arduino, and a strategic advisor with Platform IO. Ladies and gentlemen, Kathy Giori.
Hello, everyone. Welcome virtually to my home in California. I'm in the San Francisco Bay Area, and I'm going to give you a short presentation about why I like my smart home to be private and secure. And then I'm going to actually walk around and show you things. And then I'm going to show you how you can sort of make your own smart things as well. So I'm going to start out by sharing a presentation, only a few slides. Hold on a moment, and I'm going to share a specific window. Okay, hopefully you can see all this okay. What I want to say is the project that I worked on at Mozilla is actually, because Mozilla had financial woes, it's being spun out. Mozilla doesn't have the resources to fund it anymore. So I'm part of a group of a couple engineers supporting the spin out as best I can. I also spend a lot of my time on microblocks right now at microblocks.fun. You can find it, and it has built-in web things libraries, so that's pretty cool. So let's start with the smart home. I don't know if any of you have used smart home devices, but if you get interested in them, the things that I care about the most are things like security. You know, I don't want things that are making it vulnerable for hackers to attack my internal network. I really care about my privacy because all of these comings and goings and motions on and off and doors opening and closing, especially video cameras, if other people are looking at all that, it feels creepy. And it's in the wrong hands can really be a problem. Interoperability. Right now, you buy things and you get stuck in these vendor ecosystems. And, you know, how can I make this doorbell push cause this other action to occur outside of the vendor's specific use case? And then overall, you know, how long do these things last? It's worth my time and money and effort to put all this in. And hopefully I can convince you today that right now, basically doing it yourself is a pretty fun way to go. Now, I mentioned privacy. The important thing for me is that typical vendors, you buy a product, let's say this Samsung SmartThings button, and it connects to some gateway, and then that somehow the data from it goes to their cloud, and then you load an app on your smartphone, and then with your app, you can interact with these devices. You end up having tons of apps and all your data is scattered about the clouds, or maybe you go into one ecosystem and it's all in one cloud, whatever. But we've totally turned that upside down. Instead, what I'm going to show you today is a gateway that's running only on a lowly Raspberry Pi, like this, and all your data stays on the flash memory of that Raspberry Pi. You can back it up locally. You could even back it up to the cloud, but basically it's all your data. It's all private. And when you access remote data, there's an HTTPS tunnel service that you can use, or you could open a firewall port, but most people don't know how to do that. So there's a tunneling service that Mozilla is hosting that we're going to try to continue. Now, the other thing I mentioned is when you buy different vendors, things don't work with each other. And so in Mozilla, we worked with the W3C Web of Things initiative that says, it doesn't matter what all the different radios and protocols and things you buy, what you want to do is you want to tie them together at an application level. So at the application level, you have the definition of a light, the definition of a button, the definition of temperature, and it's just JSON. And there's another project that was announced last year called Project Connected Home over IP. It's somewhat similar, but not a W3C initiative. And I think they can go together because interoperability from web to IP layer should be doable. And again, what you have in my scenario is a gateway. You buy your stuff off the shelf in stores, or you can build your own, and all of it's private to you. Now, the frameworks of devices that you would build your own, we've developed many different libraries in different languages, and one of which I'll show you is the microblocks framework. But there's a lot of different third-party libraries, and basically it's just creating this JSON structure. And then I'll show you, I have a tutorial that I wrote up of how to put this all together. And wow, I'm done with the slides. Can you imagine that? It's ready for demo time. So I'm going to stop sharing this slide, and I'm going to get ready to get up and walk around my house. And I think before I do that, I'll just pull up my gateway screen, which is going to be here. And all right, now I just have to find that screen. Okay, here I'm on that screen. And now I'm going to walk around the house. And this is where Jared might double my screen, but I can just start out with this being a Samsung SmartThings button. And I created a rule for the lamp that's above my desk that 1 click will turn the light on and 2 clicks would turn it off. I also, this button actually has supports a long press as well. So I can do, I can turn it on, and if I hold a long press, I change it to max brightness. And if you look inside this light bulb, it has an on off and it has a brightness. So again, I can change the brightness through the web. I can turn it on and off through the web. And the way that I did this with a rule is this is where the JSON comes together. Whoops, I'm way down at the bottom. Is the rule is simply when this desk button is action event or event pressed out of different things that this button can show, then the desk will turn on. So I have it pressed to turn on, double press to turn off, long press for max brightness. And if I look inside this button, the definition of it is that it can tell me low battery voltage and temperature. So all of the Samsung SmartThings buttons actually have temperature in them, which is something I really like. It's pretty cool. So now we're going to walk around the rest of the house, and I'll show you a few things, including, we'll start with a camera that points out the front of my house. So I can do a snapshot, see what that looks like. And now if you can see my camera, this is the camera and the view that it's seeing. So the view should be somewhat similar. All right. And now I'm going to walk around, just going to kind of go around the house. I have a front entryway, and up here is a little Xiaomi door sensor. And that would be this, let's see, let me find it. Gotta find the front door. Well, if I open the door, I'll figure it out. There we go. Okay, so the Xiaomi door sensor is not detected as a door sensor specifically, but it's got, basically it's like a binary sensor. So it's open, it's active, it's closed, it's inactive. So I walk out here, and then I have this IKEA remote, and we're gonna walk out the front door, and I'm gonna get porch motion detected. That's a little motion sensor that's just like surreptitiously sitting down there. And then it's kind of bright out here, but we're gonna look down here, and you see this string of LEDs? If all goes well, this garden button with such an IKEA remote, turn on this string of light. And then I actually color coded the image that I put on there
Hello, Kathy. Sorry, just be careful with your microphone here.
Oh, maybe
Yeah,
I'm
you're back
covering
now.
it.
Thank you.
Okay, I was holding it wrong. Okay, and then different colors like purple, and then we'll go back to white. And then I can turn it on and off. So it's handy. You can have a button. I can click the web and do other things with that. And so, and I don't know if you could hear, but I walked in the door and I could still hear basically my homemade doorbell, which it's not really a doorbell, but it's motion. So remember I had that porch motion area detected with that little motion sensor. I have a rule that says down here somewhere. Okay, let me scroll down. I have lots of rules. Here it is. So when porch motion is detected, do a notification and do a little announcement. And so what's going to happen here is I'm going to just show you, I'm going to pretend. I'll show you with the Google Home. So I pre-canned messages for the Google Home, and one of them is porch motion. So let's see if you can hear that.
Front porch motion detected.
Okay, and then recently we've had a lot of fires in California, and I set up, I announced to one guy who's in Germany, can you set up a link to this Purple Air? It's a website. So all this web data, you can fetch data from the web as well as push data to the web. And so we brought in these data from Purple Air, and here's one of the sensors that's close by within a kilometer. And this air quality index right here, 74, as long as it's below 100, it's moderate. Between 0 and 50 is good, 50 to 100 is moderate, and over 100, it's bad. And so what I have now is a rule also for if it goes over 100, I want it to let us know. So let me know.
Check air quality. It's moving from moderate to unhealthy.
And then I have intruder alerts and leaks under the sink detected, significant earthquakes over 5.0. And you can just like play around. You can say, you know, hi, IEEE students and professionals. And I say that at volume 45.
Hi, IEEE students and professionals.
So as you can see, you instead of just beeps and alerts and things like that, with a text-to-speech engine, and it doesn't have to be the Google Home, but this is just a great example. A text-to-speech engine, you can have, you know, custom things happen all the time. Now on the voice side of things, instead of that was text-to-speech. Now on speech-to-text, this gateway sitting right here, this is the Raspberry Pi gateway. This is the Zigbee dongle. Here's the Jabra speaker microphone. This is an example of a Xiaomi push button and a Samsung motion detector. And I'm going to show you how I can use my voice. Hey Mozilla, turn study on. Okay, and that's a light that's right over there. And then that light goes on. I have this Sonos and a virtual button that turns on this music right here. And if I change the volume higher, whoops, I turned it off. Turn it back on. And then I can do the light, and I can, you know, do things like change the color, any of the properties. So this study is a color light, so I can say, hey Mozilla, turn study blue. And you can see that it turned the light to blue. And then there's other things. You see the TV area motion is detecting me. And there's, like I said, the Samsung all this Samsung door sensor here also has temperature. So when I open that, you see this entry door right here is now open, and it also knows the temperature. And the leak detector under the sink knows the temperature. So some things have those things and some things don't. Right here in the kitchen, I have a motion. This is, I call the back deck motion. It just sits out in the window and looks out in the back. There's a back deck with a string of lights. I can use my voice, or I could use just the button. But as you can see here, I've turned on the string, and I don't know if you can see the lights, but they turn on. And then conveniently, I don't know if you can see, there's the these buttons right here, house and everything, are just 1 second pulses. And all I do with them is I use them as rules. So if I turn on, oops, I didn't mean to do that. If I turn on the house, I turn on a bunch of lights. And then I might want to use my voice. And I could say turn on the house with my voice, but I can also say, hey Mozilla, turn everything off. And as you can see, this is just a rule that says when everything is changed to event off, turn stuff off. Now, there's a couple more convenient things that I thought I would show you. I'm not going to show you everything here, but there's a whole bunch of stuff down on the bottom that are bringing data from the web in, and then I can take alerts. So I have an upper deck door right here. And when that door is open and the temperature is over 22 degrees Celsius, then the fan will turn on. So there's the door sensor up there. And if I open that, the fan doesn't turn on. But I have a rule that says, let's see. Well, a couple rules. If the upper deck door's temperature is greater than 22 and the door is on, turn on the fan while it's open. So then if I close the door, the fan will automatically turn off. And the other thing that's cool is that if there's bad air, so if the air quality index goes over 100 and the upper deck door is open like we're sleeping at night, then every minute it announces bad air on the upstairs Google Mini. So you can see you can sort of, create your own types of rules, your own types of conditions. It's all quite fun. Now, I did the walk around so you have a sense of what some of these things are. Now, if I look, I'm just going to sit down and get comfortable again. If I look at the entry door data, you can see when it's been opened and closed. So when you're going around normal workday pre-COVID, if you were to see these data on a week schedule, you can see that someone's here, that they're sleeping at night, they're gone all day. Stuff like motion detectors would tell you that as well. That's why it's important not to share these data with other people. Like I said, all the Samsung buttons have temperature in them, so I can take a look at those. I have a specific just temperature sensor in the laundry. And then this weather is the outside weather at Stanford, and I pull that in from the internet using one of these add-ons. I also monitor the earthquakes, porch motion, back deck motion, the tide in Redwood City because I go rowing on the bay, and then sink upper deck temperature. And then these are recent graphs, which is basically the air quality index. So you saw that we were up in the way high hundreds, and then we had a change in the winds, so they came in from the ocean, and now we're creeping back up a little bit. We're up in the 70s, but still better than it was before. Okay, so I'm going to show you just under, and you can look at all on a floor plan too. Like this is a floor plan of my house, so I can go around and you can actually click things on and off. So I'm over here where this light is, and I can actually turn on the light right from the floor plan. I actually prefer the bigger view, but because I know where everything is. Now, another thing, I'm not going to go through all these settings, but basically the add-ons is where things get really cool, because this allows you to connect up with a whole bunch of other devices. So that camera I had was on with. And for this, basically what I'm going to do is I'm going to share this. Hopefully there's a place to share in the chat, because I have this tutorial. Let's go back here. And that talks about how to take one of these Raspberry Pis and set it up from scratch. Now online, you can also see how to do it elsewhere. You can also download it for Docker or just install it on various Linux distros. But I find this incredibly useful because they're cheap. And you just download an image, you flash it onto the SD card right in the back there. I use Balena Etcher to flash it. And you power it up. And there's basically 3 main steps. You connect it to your local Wi-Fi. It acts as an access point so you can find it. You point it to your local Wi-Fi. You give it the password of your local Wi-Fi. Make sure it's connected. And then you give it a subdomain. Now this subdomain off of .mozillaIoT.org is going to change pretty soon to some other domain, webthings.io. But for now, this still works. And you can reclaim a subdomain, and then you create your first user account, and then you start adding devices. And so this whole tutorial has all of that setup steps, and then all the way down to, you know, add-ons and things like localization, you know, picking your language. And all of these languages, you know, are volunteers, same volunteers that do Firefox translations, a lot of them. And then you can do various other developer mode stuff. So it's all pretty fun. And I spent a whole lot of time talking about a few specific add-ons, like, and that's where I'm going to go back here and talk about, you know, the earthquake monitor. How would I configure that? I say where I am and what my latitude, longitude, or what I want to call it, how far I want to go, and the minimum magnitude and the polling interval. And then what does that turn into? It turns into a thing. So I go back to my main page here, and I have my Stanford earthquakes, and it will tell me this information. And then logs, you can add as many logs as you want. You can log properties for whatever you want to log. So, and then this weather is also coming from the internet, and I can compare this weather to my indoor temperature. All right. I'm sure there's more things I want to cover here. Oh, Slack. I use Slack for notifications because I just send myself a direct message. Oh, and those voice commands that I was doing, if I want to check in the event log, I can see those commands that I was doing. And it's very important to know those voice commands are processed on Deep Speech on the Raspberry Pi 4. They are not going to the cloud. Nobody else is seeing your commands and what you're doing. So there's a wake word that you can configure whatever you want it to be. Just pick something with lots of vowels so it will detect it, and then it shows you what speech input you said. It's not perfect, but it's getting better. So I'm going to now, let's see, jump into the mode of showing you. I have another Raspberry Pi sitting here on my desk right there. And we're going to do a little bit of development, starting with this little thing is called a M5 Atom. And I already programmed this one. This one is programmed as a little doorbell. And then, and as you can see, when I boot it up, it's actually showing me its IP address that I got, because one of the blocks is to give it an IP address. And then it's got a little piezo, a little sound thing for the doorbell sound. And then I have this motion sensor. I'm going to turn this on. This is an M5 stack. It's got a built-in battery, lots of cool stuff. It also is programmed with microblocks. You can see the IP address. And so these two things just came online, and you see it's got motion detector. And so if you can see my screen, it looks the same as my commercial devices, right? And yet these are things I just made. So if we push the doorbell, you can see that the doorbell now just was pushed. And if we go into the event log, you'll see that the event pressed 6 seconds ago when I pressed it. And so now with these things, I'm just going to show you how fun it is to make your own. This temperature and light sensor, I'll show you, is just hanging. It's just coming from this microbit. I don't know if you can see it, but the microbit has light and temperature. And if I were to cover the light, which is coming in from the LED arrays, you see it goes to 0. And so one of the things we can do, just quickly to show you how logging works, is I say, oh, here's the, I already have the light being logged. So let's look on a minute basis. And then as I'm covering the light or covering the sensors, it goes down. And if I uncover with my hand, it comes back up. And so you can look at that on a, on different bases. And this was my air quality. So I actually hooked up my own indoor air quality sensor. It's not the same units, but it gives me a sense of things. Let's see, I'm going to show you how to make some of these things. Okay, and again, this switch and this stuff are just my virtual, it's like house and everything. It's like my virtual 1 second, turn it on for a second, turn it off, and I use the event to do something else. But I'm going to make a couple of things. Oh, 2 more things that I already made is I have these cute cat ears that are LEDs, and I have another microbit. So I hook up the LEDs, and it also has a sound sensor. And then I have another microbit connected to the Raspberry Pi, and that microbit connected to the Raspberry Pi is called Happy Birthday. And it just has 2 properties, an on-off and a sing. And so it sends a radio message actually from the one here connected to the Raspberry Pi to this one. And I could click the web button to turn it on. And you can see that my my cat ears just went on. And then if I want it to sing, I click this button and it will sing and then time out. And my LEDs are actually cycling. They rotate every 4. And so I wrote all this stuff with microblocks literally this morning. Like none of this was done, and I was having trouble sleeping, so I woke up and I made all these things, kind of fun things to go. And you can also, like the same on-off button is here. If I push both these buttons, then things turn off like that. And if I push this button again, I can turn it back on. And if I push the B button, it's going to play the music again. So these are the kinds of fun things you can make. And, what if we want to just tie a rule together, is we could tie the on-off of Happy Birthday to, for example, I want to turn it off when I say turn off all the stuff. So I could create a rule that says when stuff is turned off, actually, let's do event turned off, then we're going to turn off Happy Birthday. Okay, stuff off. And so what happens now is here's my Happy Birthday on, and I just click stuff off, and Happy Birthday comes off. Now, how hard is it to make these things? Well, it's not that hard. I'm going to show you doing that with microblocks next. But before I do, I'll just show you IoT.mozilla.org is going to be moving to a new website. Where right now, IoT.mozilla.org is the place to go. All the add-ons for the commercial stuff, this is kind of like apps for your smartphone. And by the way, you can do it all on your smartphone too. All right, so this lamp right here, turning on and off, it's all browser based, so you can do it from anywhere. All of these things are contributed when you click on the person's name. it takes you to the GitHub account with the open source of all of these add-ons. So if you have Chromecast devices and LG TVs and all this commercial stuff, if somebody's written an adapter for it, then you can just bring it into your central place of your private smart home. And there's a bunch of, connect your own built devices too. And then there are notifications. Anyway, so those are add-ons. The Web of Things itself, like before I show you the blocks based in microblocks, behind the scenes is all JSON. So these are the different capabilities that we've defined that turn it into an icon. So the things I'm making here with microbits have no idea that what the icon of the user interface, that's being done on the Raspberry Pi. So there's properties, actions, and events that make up these things. And all the source is hosted on GitHub at webthings.io. And webthings.io is going to be the new site. What this is now is going to be rebuilt and end up here. And then microblocks is what I'm going to show you how to build them. So if you go to microblocks.fun, there are some activity cards here already, web lights, web buttons, some other fun things, LED. And that's what I'm going to show you right away. Like Hello LED is sort of the Arduino Blink of getting started. And so I have this little microcontroller and a bright LED so you can see the light better than the built-in user LED. And I'll just show you how simple it is to make something. So stop sharing for a moment so I can bring up microblocks. And now I think I'm going to share my whole screen so that I can flip back and forth between microblocks and the gateway user interface. So when I plug this in, it also already has a virtual machine. And so this little green button, oh wait, I need to share. Sorry. Okay, share screen. Entire screen, yeah. Okay, now hopefully you see my microblocks window, and hopefully you also see my camera. You can test things really quickly. I happen to know that this LED is on pin 5. So if I wanted to test it, microblocks is live. It just turns right on. I can turn it off. Boom. So this green says it's connected to the LED. So how hard is it to create a web thing? Well, I could build it from scratch, but it's faster if I just fetch my example, IoT bus, and I have my Hello LED. So this is going to open this example, and I have a local just demo gateway or demo access point. This isn't my home access point, so I'm not giving away my Wi-Fi credentials. So you can try it later and it won't work. But this basically, when I click start, well, before I do that, Wi-Fi connect to a network, set the thing name. This is from the Wi-Fi library and then the web thing library. And you can describe what type of property it is and what type of capability it is. And so this is going to be a light with just one property. And I turn this thing on, and it's going to get an IP address, 192. And then I fetch, I go back over to my gateway, and I say, okay, go find 192.168.8.192. Submit that, go fetch it, and it sees the JSON, save that, and I say done. And so now I have this thing that's connected over Wi-Fi. Now you think I'm probably cheating because I'm still connected to microblocks, right? But I'll show you in a minute. I just want to check it first. But if I click Hello LED, yay verily, I now have a web thing. And if I jump back over here, I can show the IP address. I can show the thing description. And so this is the JSON. If I were to load in my browser that same IP address, I would see this JSON in a pretty format, basically, is what it would amount to. And then I can also test it from here. I can click it on and off from here, and turning that on, there's a 5-second polling rate that occurs over here, and you see the result over here. So if this had a button, I could turn it on and off as well directly from the thing, a physical button as well as a web button, as well as use my voice if I installed the voice controller. So now you can do things like update our rule and say, when I turn stuff off, turn that off, turn off happy birthday and turn off hello LED, right? So now I have turned them both off. Go back over here and I say stuff off, boom, it's gone. And then this unplugged, it'll go disconnect, but I'll plug it in over here, and I'm just applying power, basically like plugging in batteries of things, and I'll still be able to control it once and then there it's on and there it's off. And the last one I want to do is just this little ambulance, and I can show you that, oh, it's playing a Simon game. Show you that there are built-in examples. Okay, it doesn't have the latest firmware, so I'll say, yeah, go ahead and update it. Let's see, I need to update firmware. And so it's loading a virtual machine onto Microblocks. And there are examples, lots and lots of examples. So if I go in, these are built-in examples. There are built-in Web of Things examples like this ambulance. And if I open that up, then this is a slightly more complicated web thing. This circuit playground has a radio. It's the Bluefruit model, kind of like the microbit. They can talk to each other. And I can run this example, and it's got like 3 different properties and becomes an ambulance, and I can test it. And all I have to do is unplug it. And then I plug it into my Raspberry Pi, or I create a radio link to it, but it's faster just to plug it in. And so now it's no longer connected to Microblocks, and I should be able to, it'll just find it, plug it into my Raspberry Pi. There's my ambulance. I save, I'm done. And now let's create a quick rule where we say when the motion is detected, we're going to turn, while the motion is detected, we're going to turn on the ambulance. Whoops. Okay, so one more quick thing. Motion. And you can do while this and this, while this or that, if this and that. Lots of different things you can do there. So while the motion is on, we'll have the ambulance triggered. So I'm using this as kind of an alarm. And so now my motion sensor is sitting over there. Let's trigger it. Okay. And as soon as that motion sensor goes off, oh, I did an if. Ah, that was my bad. Okay, so what I meant to do was, in this rule, change this if to a while. Okay. Anyway, you get the idea. Then if I do this motion, it would go off, and then it would come back on. All right, so I think I have copied, I'm going to stop sharing. I'm running out of time. I think I've copied the Web Things Gateway tutorial, and then there are lots of different, a few different IoT introductory cards on the microblocks.fun website, and there's, I have some other documents coming in that light as well. But yeah, somebody just noticed my Code in Place t-shirt, so I actually did the Code in Place thing at the beginning of the COVID because I didn't really know Python that well, so that was a lot of fun. Hope some of you did it too. So I'm going to stop there. I think I stopped sharing, and I wanted to see if I could bring in some questions. In fact, I'm going to need this to read the questions. So is a smart home necessarily connected to the net? No, in fact, the other day my internet was down, but my smart home still worked, right? So the only things that don't work is the things I'm pulling in from the internet. So I'm bringing in weather, air quality sensors that are external, tied from road to city. Those things would be not working when my internet access at my home is down. But when my local internet was down, my modem, I had to reboot it, but my local Wi-Fi, which I have an external router, was still working, and the Zigbee stuff or other protocols were still working. So where can we download project files for this? Okay, so the two main things I talked about were 1, the gateway, and 2, how to make some of this fun stuff. And so the two places I would say are, right now it's iot.mozilla.org is sort of the starting place, and it shows you GitHub WebThings.io. And then microblocks.fun has the source code repositories. If you go to microblocks.fun, you'll find all that as well. So do you have an idea about the number of smart homes in the US? I don't know. I did a survey when I was at Mozilla, and the #1 item that people had were smart speakers. And that penetration is like 10 or 20%, or actually more, quite a bit. But the number of people who had the devices, I think, is still relatively small in its infancy. Design of smart homes for blind people. So the beauty of this system is it's not tied to what the commercial vendor wants you to be able to do. So you could actually create the types of rules that a blind person would need. Voice is, going to be a huge benefit for someone who's blind, but there could also be just buttons or sounds, or you can basically create any input, a sensor, and then direct an action out of it. So those are sort of cool. Can you tell us which version of the Raspberry Pi? It will run on all the versions of Raspberry Pi, but I've run it on a Raspberry Pi Zero W wireless, and it was sluggish. So if you want to run the voice controller, you need a Pi 4. Everything else, I'd say a Pi 3 is probably your best option, but people have run it on Pi 2s and original Pis. I mean, it's just going to be sluggish because it has to serve up that web interface, which has a lot of Node.js going on. So I recommend our Pi 3 or 4. The number of technicians can install a smart home. So why is there no field of study for this branch? It's relatively new is what I would guess. And really for consumers, the reason it hasn't, I think smart homes haven't taken off is it is such a barrier for not as tech savvy people to figure out. And even myself, tech savvy, there's some products that I will never buy again because their discovery and setup and onboarding process is so onerous. It's just terrible. And then the privacy aspect of a lot of them is sketchy too. So I think you got to watch out a little bit. So raise your hand if you're gonna build your own smart home. And raise your hand if you're gonna run microblocks. And teach your friends. And teach students. Go back to your communities or younger brothers and sisters, tell them all how to do it. It's really quite cool. And if there isn't any other questions, I was hoping I wouldn't run out of time, so hopefully I haven't. Oh my blind down. Oops! I just had motion because I reached in front of my motion detector. But okay, there we go.
Hi, Kathy. Thanks very much for showing us around your house, and you had me absolutely terrified while you were walking around your house that you were going to fall. So thanks for the extra pressure.
No, I'm hoping, like I put the link for a tutorial that I'd written, and I know it was back in June that I wrote it, and I need to update it, but I'll try to update it in that same place so that it's mostly fine the way it is.
Awesome. And then you were saying that the website might move address. What was the name of the new website that it might be? Or will the old website point to the new one?
So the new website is webthings.io. And the current website is iot.mozilla.org. In fact, I can put that in the chat here. So old, new.
Perfect. And
there's a chat server that is still hosted on Mozilla's chat server, the IoT channel, and a discourse still hosted by Mozilla IoT channel on discourse. Those are great places to talk to the community and just issues on GitHub in the various repositories.
Cool. And I've seen that you had IKEA stuff as well, so I assume that the system works with both Bluetooth and Wi-Fi and...
Yeah, so IKEA right now is Zigbee, and so does Samsung SmartThings. All these battery operated stuff, really low power stuff is Zigbee. So I had that little, it looks like a memory stick. Turn off the motion sensor. There we go. All right, motion sensor off. So Zigbee is super convenient because it's totally private. It can't talk out to the cloud if it wanted to. And then you just need one of these little dongles that you stick into the Raspberry Pi. And there's a ConV2 dongle. In fact, I'll write that down. It works really well. ConV2. That right? And you stick that in there, and then all these things work locally. And again, they don't need the internet. They just work locally. And all the IKEA TradFri products, TRADFRI. In fact, that Sonos speaker I have is also an IKEA Sonos speaker, but there's a Sonos add-on. So that's the other thing is if you're a web developer or JSON developer or any sort of language, building add-ons is kind of like building apps for the phone, only instead of having all sorts of different apps for all these smart things, add-ons tie everything back to the web. So you can, involve these rules and the interface all in one place. So building add-ons is another great place for people to start.
And I guess it's all open source as well. I mean,
100%. Microblocks, education focused, 100% open source. If you've heard of Scratch, John Maloney did Scratch for the first decade plus of his life. John Maloney is the lead developer of Microblocks. Amazing. And yeah, all of the Mozilla software is also 100% open source, and it's been spun out to stay open.
Cool. Thank you. Thank you so much, Kathy, for your time. Hopefully we can have you again soon. Hopefully the next time it will be at an in-person event.
Yeah, and if you try it out, again, the active place to go is the chat server on Mozilla. So it's chat.mozilla.org, the IoT channel, and I'm on there. Like, people will help you if you get stuck, run into any problems. Just join the community and have some fun.
Awesome. Thank you very much.
Great.
Next up, we have the entrepreneurship finals. They will be starting shortly in 4 minutes. I think they're still waiting for one of the judges, but so you have time to get a cup of coffee before that starts. And we'll see you all again soon. Thank you and goodbye.